Gymnotiforms are an order of neotropical knifefish. Neotropical referring to the biogeographical region of southern Central and South America, including the Amazon rainforest. Gymnotiforms vary greatly across species, from the world-renowned electric eel, which isn't an eel at all, to an array of small fish you would likely overlook. Studies of gymnotiforms began with Alexander von Humboldt's research on electric eels, proving the concept of natural electricity. This led to Michael Faraday, famous for Faraday's law, electric eel research focusing on electromagnetism. The study of neotropical diversity started with Carl H. Eigenmann, a student of David Starr Jordan, the founding president of Stanford University and personal friend of Woodrow Wilson. And perhaps surprisingly, even Charles Darwin himself is cited referring to the, quote, pseudo-electric organ of gymnotiforms because they have what looks like an electric organ of electric eels, but its discharges are too weak to be detected without amplifiers. After World War II, scientists gained the technology of amplifiers and documented electric communication for the first time. The news and research interest in gymnotiforms grew, and today they have been divided into 5 families with over 250 species. The discovery of gymnotiforms had a slow start and began with the largest species, and as time went on and more scientists emerged with new technologies, more smaller species were discovered. These figures from Tagliacolo et al. 2019 show that, with Figure 2 showing the number of species has increased with publication date, and Figure 3 showing how the body size of those species decreases with publication date. The biodiversity patterns commonly studied in gymnotiforms are species richness, species endemism, phylogenetic diversity, functional diversity including diet, habitat, and behavior, and morphology. Gymnotiforms are endemic to the neotropical region and have their highest diversity in the Amazon River basin. Of the 5 families of gymnotiforms, we see 2 different types of electric signal: wave-type electric organ discharges, EODs, and pulse-type EODs. The families with wave-type EODs are Sternopygidae and Apteronodidae. The families with pulse-type EODs are Gymnotidae, Hypopomidae, and Rampictidae. Each family has its own rich history and phylogeny, but the most species-rich family is Apteronodidae, with approximately 96 species. One genus of Sternopygidae is Eigenmannia, named after Carl H. Eigenmann. It is currently believed that the majority of gymnotiforms eat insects and crustaceans. They use their electric organs for both location of prey and to communicate with one another. However, this is very complex, and the functional diversity of these fishes varies greatly amongst family, genuses, and even species and within species. For example, Steatogenes elegans, a species in the Hypopomidae family, is currently believed to have 2 different color morphologies and behaves differently between the 2 morphs. One is a light color and stays near the top of the water, while the other is darkly colored and goes to the bottom of the water to sit on leaf litter. However, there are ongoing studies to determine why they may act differently, and if they are in fact the same species as they are currently identified. In ichthyology, we find that the phylogenies and clades of fishes are almost constantly changing, and as new technologies arise, so do more in-depth studies. One type of study is referred to as a model-based total evidence phylogeny, which uses known phylogenies, genetics, biogeography, behavior, and very in-depth morphology with CT scanning and photogrammetry to make the most accurate phylogeny for a clade as is possible. Some people might find the constant changing of phylogeny to be annoying and difficult to keep up with. However, the more in-depth research allows us to form the most accurate understanding of the natural world and gives us an opportunity to provide the most needed resource: protection. The Amazon is under the threat from global climate change, land use change such as deforestation and forest degradation, poaching, and damming. All threats to the Amazon are threats to the fish that inhabit it. So gaining a better understanding of gymnotiform habitats, behavior, and diets will help us understand how they might be affected by current threats to the Amazon and what we could most immediately do to help them maintain biodiversity.